Welcome back to Applied Mathematics. In this video, we're going to be factoring trinomials. As we've seen in the previous video on factoring, this is unfortunately going to be a very abstract video. I'm not going to be able to get to the applications yet by the time we're done with it, but I promise that they are on the horizon. This is also one of the few videos in this course that really directly builds on the previous work. I am going to use the grouping method. Sometimes referred to as the AC method, as my tool for factoring trinomials. It's not the only option, and if you're familiar with a different way of writing out the process of factoring trinomials, you are welcome to use that instead. But this is the way I'm going to be writing it out. And no matter what approach you use, you should get the same result. All right, but let me get my head out of the way. And before we get any further, I guess I should write down what is a trinomial. All right, well, it's got this nomial in it, which is referring to a polynomial. Right? Things that are formed by adding and subtracting terms that have variables to various powers. And the prefix here is tri. Like a triceratops, a tripod, or a tricycle, a trinomial is going to involve the number 3. Specifically, a trinomial is a polynomial that has 3 terms. Generally speaking, we're going to write this as sum a times x squared plus sum b times x plus c. And this is where the name of the AC method comes in. We're going to be looking at the lead coefficient a and the constant term c, and trying to use those as our basis for solving or for factoring the polynomial. So let's jump into a relatively straightforward example. X squared plus 5x minus 24. In this particular example, a is equal to 1, b is equal to 5, and c is equal to negative 24. That means that a times c is equal to negative 24. Now I'm going to list all of the possible factors of negative 24. Well, actually I'm going to list half of them. I'm going to turn to the one I didn't pay attention to, b in this case. If b is a positive number, then I'm going to choose my factors so that the larger number is positive. If b were a negative number, I would choose my factors so that the larger number was negative. Right. So for example, I could write negative 24 as 1 times negative 24, or as negative 1 times 24. Because b is positive, I do not want the version that has the larger negative number. I do want the version that has the larger positive number. And then if it's been a while since you have thought about listing the factors of a number, a trick that I've always enjoyed. Start with 1, or in this case, start with negative 1. And then just keep increasing or decreasing. So after negative 1, I'm going to try negative 2. Negative 24 divided by negative 2 is 12. Then I'll try negative 3. Negative 24 divided by negative 3 is 8. I'll try negative 4. Negative 24 divided by negative 4 is positive 6. I will try negative 5. That doesn't work out. The next number would be negative 6. Well, I've already got 6 on the board. I've already written, well, positive 6, but I've already got 6. And the fact that I have that is my indication that it's time to stop. I've gotten everything that there is to get. Now we come back to our value b. If I add the factors that I've just written down, if I try adding negative, negative 1 plus 24, I get 23. Negative 2 plus 12, I get 10. Negative 3 plus 8, I get 5. Negative 4 plus 6, I get 2. I have a winner. 5 is negative 3 plus 8. If there is no option here where they add up to give you the value of that middle term b, then you're going to have a trinomial that cannot be factored. I don't have that situation. I've got this working perfectly fine. So I'm going to expand out, rewriting my polynomial. Instead of writing it as x squared plus 5x minus 24, I'm going to write it as x squared minus 3x plus 8x minus 24. Now I have gone from having 3 terms to having 4 terms. And once I have 4 terms, I can factor by grouping. In the first group, there's a common factor of x. When I factor that out, it leaves behind x minus 3. In the second group, there's a common factor of 8. When I factor that out, it leaves behind x minus 3. Now, since I got an x minus 3 in both cases, I will have an x plus 8. If you have made no mistakes getting to this line, then factoring by grouping will always work. It will always work out perfectly for you to factor by grouping if you did finding the factors correctly, if you rewrote the expression correctly, if you didn't make a mistake with your calculations or with a sign error. If factoring by grouping does not work, that is an indication that you made a mistake. Go back, look at your list of factors again, make sure that you have them correctly. Look at your sums again, make sure that they actually add up to the middle guy. Look at your positives and negatives and make sure that you didn't make a sign error. But there are times when it just doesn't work. You will find nothing on the list that actually adds to your middle term, in which case factoring is still not going to work. But as long as there is something there, the process will work. Let's take a look at one more example. Three x squared minus 7x minus 6. In this case, a is positive 3, b is negative 7, c is negative 6. If you find it helpful to write those things down, go right ahead and do so, although technically speaking, it's not required. And then we're going to use the AC approach again. So I want to multiply a times c. 3 times negative 6 is negative 18. In this case, our b is negative 7. So I want to choose to write down my factors so that the larger number is negative. Because AC is a negative value itself, that means that the smaller number will be positive. They're not going to be the same sign, but that's not really the important thing just yet. Right, so I'm going to have 1 times negative 18. I'm going to have 2 times negative 9. I'm going to have 3 times -6, 4 does not work, 5 does not work, 6 is already on the list. Those are all of the factors. And then I'm going to test. 1 minus 18 is -17. That's not what we want. 2 minus 9 is -7. That's exactly what we want. We don't even need to check, but I will anyway. 3 minus 6 is -3, which doesn't work. We have an option that works. We can factor this trinomial. So I will rewrite this. 3x squared plus 2x minus 9x minus 6. I will group things. In 3x and 2x, there's a common factor of x, leaving behind 3x plus 2. Then I'm going to factor out a negative along with the common factor of 3. -3 times positive 3x gives me minus 9x, and -3 times positive 2 gives me minus 6. So that 3x plus 2 comes out, and an x minus 3 is left behind. I don't have a lot more to say on this process. Just getting experience, practicing it, learning how to quickly identify A, B, and C, how to write those out, and how to churn through this process just takes practice. It takes doing, it takes repetition. But watching me is not going to help you, so I'm not going to make this video any longer than it needs to be. I'll wrap up instead with this, and I'll see you in the next video.